Hi, everyone. Thanks for joining us. We're going to get started in about a minute, so thank you for waiting. All right, so we're going to go ahead and get started. So hello, everyone, and thank you for joining us today. On behalf of the Environmental Finance Center Network, welcome to our first session in our Onsite Wastewater webinar series, Onsite Wastewater System Basics. My name is Avery Davis from the Syracuse University Environmental Finance Center. And before we begin, we're going to cover a few logistics and then we'll get started. During the webinar today, everyone will be kept on mute to ensure audio quality. If you have a question, please type it into the GoToWebinar question dialog box anytime throughout the session. We will be saving your questions for a facilitated Q&A session at the end of the presentation. After the webinar, you will all receive a follow-up email that includes a link to the recording and other information you may need. You can also download the slides from today and the Handouts tab in your GoToWebinar control panel. This webinar has not been submitted for pre-approval of continuing education credits, but eligible attendees will receive a certificate of attendance for their personal record. To receive a certificate for this session, we ask that you attend the entire webinar and register and attend individually using your real name and unique email address. We do not accept group viewing credits, so if you're viewing as a group, we do encourage you to log on individually so that you can receive your certificates. Certificates will be sent within 30 days of the webinar date via email. And if you have any questions for us or need assistance, please contact us at smallsystems@syr.edu. Now for a little bit about us. The Environmental Finance Center Network provides training and technical assistance to small water and wastewater systems in all U.S. states and territories through our building technical, managerial, and financial capacity programs. If your community or utility needs assistance with drinking water or wastewater system management, please feel free to contact us through our request form, which I will share shortly in the chat. And before we begin, I want to quickly highlight the second webinar in this series, On-Site Wastewater Treatment Processes. This free webinar is taking place next week on Thursday, August 22nd from 1 to 2 p.m. Eastern, and will be hosted by the Great Lakes Environmental Infrastructure Center. So I will drop a link in the chat shortly for those of you who are interested in registering. But for more information on other webinars and in this series or EFCN webinars as a whole, feel free to visit our training and events page on the website. And on that note, I would like to introduce our presenter for today, Dr. Jason Barrett. Jason is an Associate Extension Professor at Mississippi State University and is the Associate Director of the Mississippi Water Resources Research Institute. So welcome, Jason, and I'm going to hand it over to you.
All right. Can y'all see me fine? And can you see
and the slides look good. You're all set.
I'll move. I don't know that I need to see this. I'm trying to move this. All right, so are you seeing the presentation?
Yep, full screen, you're good to go.
Okay, fantastic. All right, well, good deal, and welcome everybody. If y'all did hear Avery saying we've got a series of 4 sessions that are coming up. So think about the great Greg Pearson up north with the Great Lakes is going to be doing the middle 2, and then I'll finish up with the last. But you've got on-site wastewater treatment processes coming up next. Inspection task for on-site wastewater systems would be 3rd, and then I will conclude with optimizing on-site wastewater systems. So thinking about this, I'm going to say this panel of when we're talking about or trying to get an understanding of wastewater systems, these on-site wastewater systems. Do note, I'm just trying to basically kick the anthill, or so to say, and get the conversation started about on-site wastewater systems. And before I get into that, I did want to say a couple of things. One is my initial expertise coming into water and wastewater was dealing with the public utilities themselves, the large scale public water systems, the classes 1 through 4 or 5 or A through E's, and then same thing with wastewater. That was my primary focus, and we've eased into private wells and on-site wastewater about the last decade, because there's a lot of work there. And in our part of the country, a lot of that is because there's no regulation. It's a terrible time for a university alarm to go off. But because there's no regulation on the actual, Avery, can you hear this siren?
I do hear yep, I do hear the siren. It is hard to hear over it.
Let's just give it a second. Surely it'll stop. But I can kind of talk through without hitting the presentation. But a lot of the reason we see the interest in the South here in the states that we work in is because there are no true regulations. There are no true permits to pull, or regulatory agencies that are coming out to inspect the quality. It is all the responsibility of the homeowner. So from my standing and with the MSU Extension Service, we work the entire state, plus my counterparts in others, Alabama, Georgia, Florida. We do a lot of work throughout the states just because there's a need and a desire from homeowners to know and understand what they have when it deals with private on-site wastewater systems. So with that, I'm going to kick off and start. So I would say this, one of the first things that I realized as we start looking at on-site wastewater systems is the fact that you never know as much as you think you know. Every time I do another class, are you, Avery?
Yeah, Jason, it is pretty hard to hear you. Oh, I don't. Oh, he's gone on my end. Let us see. Thanks for bearing with us, everyone. You still there, Jason?
All right, Avery, it has stopped.
I can hear you now. We are. Right. Let's start from the top. Thanks, Jason. Sorry about that.
Yeah, wherever you're from, I apologize about that. That university system, I guess they were testing the siren on campus. Not sure. Anyway, yeah, I'll kick back off. What I was saying is the more I do on-site wastewater trainings, the more I do these decentralized system trainings, the more I realize I don't know. There seems to be kind of a wrinkle or another interesting piece that I kind of pick up. So literally, as I was kind of looking through some notes and pulling some things up last night, I still see bits and pieces of things that I was not aware of and things that I kind of learn and kind of grow with. So what I'm trying to do today is really kind of hit the high notes of what are we doing? Why do we have on-site wastewater treatment? So I'm gonna kind of start with this. We think about what is it? What is on-site wastewater or sewage facility? Why are we even concerned about this when we think about also the evolution of this treatment, how these septic tanks functions, and I'm going to talk through a couple of different options that you see as far as tanks go. When should they be pumped? I'm going to try to hit those very minimal because we'll get to those in some later sessions. And I'm also finding that septic and on-site wastewater can have some, when I say regional, it may be one county, but it may be 10 counties within your state. They may have some unique characteristics based on the installers. And we're seeing this with wells and on-site wastewater or septic, that depending on the installer and how they do it, how they install. So, you know, I may go to one region of the state and it's a fairly simple two-stage, two-chambered tank with one baffle in the middle and one field line. Then we may go to another and it's an actual tank that they've added some aeration to, and it's got multiple field lines. So it just depends on where you are. I don't know that we can really down the sword of one tank or one process is better than the other, but the function, we'll get to that in just a second, is what we hope to achieve. Of course, this picture here is old school outhouse, literally just a place to go. All right, I think we're back on, yeah. One of the things I like about this picture here, and if y'all are tuned in and kind of locked into the Environmental Finance Center network, you will see we do some animations, we do some blog posts. I'm going to write a little blog about, in my mind, kind of making lemonade out of lemons. When we think about the dry season, which we are in Mississippi right now, it is very dry. So very similar to this picture right here, one of the things you may notice are these laterals that are flush and green. So you can use the dry season right now, and I'm kind of giving away what you may see or read with the blog here next month or so, is that we can use this dry season to see if we have issues. Because in this scenario here, your leach field is not necessarily draining that well. There may be some clogging in the field lines itself due to one thing or the other, fats, oils, greases, or solids being pushed down into the lines. But nonetheless, you're seeing that moisture rise as a result. You're seeing these lateral lines, which when we think about the dry season, this is one of those benefits you can have with the dry season. Next, when you look here, and I find myself saying this all the time, and y'all, some of y'all on here may have said it as well, but you know, when you flush the commode, it goes somewhere. That water is going to try to go somewhere. So, you know, in a proper operation, and again, we'll get to that in just a second, it's going through the system itself, allowing the settling and the treatment of the dispersing to happen. But if there is nowhere for it to go, you typically will see scenarios like this where it stays close to the tank, and any type of area where it can come out, it is going to come out, it's going to come to the surface. So again, this is another characteristic that you may find during the dry season, hopefully not this bad, but if you are seeing lush greenness just on top, because not all tanks access is exposed to the surface like that. Sometimes they're buried just below the surface. So you may just see a lush green area, either in kind of a circle or a rectangle, where you're having this issue. It's kind of coming to the top. All right. So when we think about this evolution, and some of y'all probably heard this over the years, when we think about the secret to pollution is dilution. And you know, from my just point of economics, when we think about how a lot of our older cities and towns were built that had some type of river or stream going through the town, a lot of times they would build their buildings with the back to the river or stream. They would just basically dump a lot of their wastewater, their discharge, just straight into the stream, and it would flow. So when we think about this disposal, you know, the effluent just goes away. We're not necessarily trying to treat it on site compared to the dispersal of having a treatment. And as we note on here, there are some public health environmental issues. And then from a management standpoint, disposal, as we said, not really any management at all. And dispersal system management is critical. So when we think about putting these, what we may call systems or tanks in place. I mean, the desire is that we're actually treating it with a safe disposal. All right, and I put this in, and again, we're talking about on-site wastewater, but one thing that we find very heavily in the South is that if somebody is on a private well, they're going to have a septic tank. So when we think about septics, when we think about private wells, I mean, I simply try to explain it as one is trying to leach it down and out into the soil, whereas a private well is pulling it back up. So I always encourage people to separate them as much as possible. And if you can, you know, knowing if there is a general aquifer flow in your area, a lot of our places in Mississippi, we see this kind of this general northeast to southwest flow of underground. So when we think about placement of wells, we may put the well in a northern or northeastern location, depending on the septic. Just trying to think about the separation and the movement of anything underground, but also thinking about what you put into the septic tank, making sure that it's not impacting the groundwater. So just trying to give that cross section so people start understanding what we have and the processes of that. All right. Ooh, so how to make these systems work? And again, this is a picture of a multi-stage here, maybe with some aeration, but getting to the topics, you know, we harp on loading of the system, and there's a chart and a graph that I'm sure all of y'all seen. Just about every state has created one as far as how much or how large of a tank do we need. And again, we'll get to that in just a second. But in my mind, I would rather size up a little bit than back. But thinking about the hydraulic and the organic loaded, so amount of water that's flowing into the tank that's going to be treated along with the organic loading that's going to go in. And this is going to be my first plug, and I hope I say it a lot. When we think about home septic, on-site wastewater, human waste and toilet paper need to be the only things going into the tank. Anything else that we may have or we may put in there very much can potentially have a negative impact on the system, and we just don't want that. All right, so evaluating the site, looking at wastewater treatment, what can be accepted. So you may be able to see leach fields, these surface lines. You may have spray heads, so there may be difference. And depending on your state, and if you don't have regulations, but you take that step to figure out what your soil will accept, that can also determine what type of outlets you have. Again, I think any of them can work if it's appropriate with your soil type. Choosing final treatment and disposal comment, we just talked about that. If there's any type of pre-treatment system, may or may not be. And again, I'm not going to weigh too heavy on operations and maintenance. All right. I know I touched on this in just a second. Now, again, I am not a sales rep for any of the tanks that we have. I've seen them all. Concretes, the plastic or fiber, the corrugated kind of plastics, fiberglasses. You've seen some, I think it's like a poly that you can also see in the ground. Everything that I have seen, if anything, it may give you kind of some longevity. But as far as treatment goes, as long as they're set up properly, your inlet and outlet pipes are constructed properly, your baffles are in, you know, I think you can get, you know, the equivalent treatment with all of them. So I'm less concerned about that. I'm gonna touch on those in just a second. When we think about detention time, typically a couple of days, 3 days, this is one of those pieces that I feel like can be an impact on that when we talk about hydraulic loading, when we think about the amount of water that's actually getting put into the system. And for those of y'all on here that may be familiar with large scale wastewater treatment, whether we're talking about a lagoon or a mechanical treatment plant, they're really no different. They're just a much larger volume, but they will also have a time span, a time frame. So when we think about like lagoon systems, we may be thinking about a 30 to 45 day life cycle. So you want to try to be able to hold 45 days of water that may be produced within your customer base. Because again, there's a time that we need, there's a time frame of kind of natural treatment that we may see in there. So detention times, talk about that. Then we think about the gravity, we think about the separation. So inlet coming in, your solids settling out. If there's any lighter pieces, they may flow over through the baffle into that secondary chamber, and you'll start to get a little bit of sludge there. So if you see it there, that's not, don't be alarmed. It's fairly common. All right, and when we think about aerobic, anaerobic, aerobic, we think about air, anaerobic, the lack thereof. All right, so here I just wanted to show y'all these pictures of the different tanks that you may see. From what I can tell, again, pricing is one of the factors, and just how deep you want to go, into those costs there. But these corrugated plastics seem to do well, and they can be a little bit cheaper. So, and again, if anybody has one preference over the other, I think that's great. We see them in multiple kinds, and they seem to work. All right, again, this is a more of a component. We're starting to get into the mechanics of it, and I know I'm gonna get into this tank again here in a second. But when we think about, again, I'm in my mind trying to dial back to when we think about just basics. What do we see and what do we have? So anytime water's leaving the house, you're going to have that tank itself, which is your initial treatment spot, where you would see your solids settling out, give you some treatment time, some detention time for the bacteria to do its job. Hopefully you're forming some type of scum layer there, and then your water would start moving out through those laterals. And depending, I've got a drain field listed here, and I know I point to gravel. Not all drain fields have gravel. Again, you'll see some of those. I got some pictures, examples we can talk through. But this one here is with a contact box, distribution box. So it goes out, and you have 4 laterals on this one. And we use our soil as very much a treatment process for anything that's filtering into the soil. It can be a phenomenal disinfectant, a phenomenal filter for that water as it moves down into our aquifers. All right, so I've got a cross section here, and one of the things that I've done again, since we've been in the arena of water and wastewater the last decade or so, dealing with septics and privates, there's very minimal regulations out there truly on the book. So you've got to find, I'm gonna say, codes or regulations where you can, because I promise you there's code to, and there's engineering design plans to how to build and construct a septic tank so that you get the appropriate settling and the appropriate treatment before discharge. Those are there, but we may not necessarily have legal requirements on the books. So a lot of times when you don't have that, you don't have any pictures, you don't have any graphs or designs to go off of. So I've tried to find or either get them created on our end so that people can have them, people can have access to them. So here is just, again, a cross section. So you look, you'll have your inlet pipe. And as you'll notice, I'm gonna say from where the inlet pipe is, the T coming down gets it, I'm gonna say, below the surface. So for one, you would hopefully never have any backflow into your actual system where your wastewater is coming from, your influent pipe. This diagram here actually has 3 risers. That's not always going to be the case. Typical that I see is you'll have 2, kind of one on each end, especially with these 2-chambered tanks like this. But you will have some type of access that goes from one chamber to the next. This one here actually has a T going up to the riser, which may not be in place, but you will have some type of baffle in the middle with a break so that the water can move over into the second chamber. And typically your outfall is going to be a little bit lower, but same thing, same process. You'll have a T pipe. So going down into the water so that you don't get any from that scum layer there, you don't get that going into your outfall pipe, because if you do, you'll definitely get some clogging into your field lines once that rolls out. And you notice here this sand gravel underneath the tank. I've seen a couple of constructions, and it depends on, again, who you've got or who's doing the work. It's not always that way, and a lot of that can be based on the type of soils that you're using, that the tank is being put in. All right. So again, you heard me talking about the scum layer. This is a little bit better visual of when we think about our influent coming in from the left here. And you also notice you just have two risers. As I've said, that's what I see very typical. You'll notice the access point right above your baffle. But it allows that scum layer to be created, but not flow into the outfall pipe, which is what we definitely don't want to happen. So you want to make sure you have those T's and they're appropriately sized. One thing I would say here, just from my experience with some installs on these, is try as best as possible when inserting those pipes. There's usually a kind of a boot or a bushing in each of those access points. In a perfect world, you're cutting out your access hole to exactly fit that boot, so that boot has no wiggle room. It is as watertight as possible, and then, you know, of course, you put your pipe in there. But sometimes I've seen that hole get cut out a little too big. The boot's in there, but it's not a solid fit, and you could get some leaking from that. So that's just a minor thing to think about. So here again, this is an actual just an image, a kind of a crafted image. And I'm gonna go to I'm gonna move this over so we can actually look at some real pictures of this here. So when we think about the baffle down here in the bottom left, just seeing that baffle there. So as far as the water flowing over, being able to go. Then when you see these, this T, and again on the right, you have a concrete tank, and see that one was cemented around, versus whereas if you have this is a concrete tank, but if you have a plastic, it'd be a rubber boot. That's what I was talking about a second ago. All right, so kind of touch on this, thinking about some screens. I have never put any of these in. You know, as y'all heard me say on the front, when we think about things that we learn and we see, and you know, as I say, the more I get into this work and the more we do it, even though I've been doing it for a while now, I see things that I was just not aware of that people may use. And you know, working with the Environmental Finance Center Network, one of the beauties of this is we get to work with people all across the country, all in different states. So we start seeing how different states may handle installs, how different states may handle effluents by actually having some of these effluent streams in there to protect the drain field, which I think is a great option. But until kind of preparing for this, we haven't necessarily seen any. I haven't had any installs. I haven't been on the site when we had any of those installs. But again, it is an option. It's one of those things that could be kind of an extra layer of protection before any of these fats, oils, greases, or solids get into that drain field. All right. I talked about this just for a second when we think about the structural condition, thinking about watertight, thinking about from a concrete tank, is anything exposed? And do realize I've had a lot of questions about this, and a lot of y'all may already know this. Tanks are holding human waste. So with that, you very likely are going to have a smell. It may have an aroma to it. Especially when we have airtight and confined tanks, there are going to be some gases, so there can be some odors that get created. So some people will make those comments like it shouldn't smell. And I'm like, you do realize this is human waste in here. So once these are open, if you're accessing them to check on it, or if you're accessing them to pump the solids, do not be surprised if there is an odor in there. All right, so let's get into some of these designs that we may see and we may think about. Distribution box. You saw earlier on one of those graphics where you have a single entry point coming into a distribution box. And this enables us to create a very easy mechanism for the water to be dispersed into multiple laterals. So like on the left here, they've got 5, and then kind of in the bottom, you see it just seems like there's just a couple there. And then on the right, actually it's the same picture, just flipped around, you're seeing the sock pipe going out, and they've actually got sand that they're backfilling over. And if you notice the darker colored soil around it, so they're actually trying to create a very, I'm gonna say, kind of porous environment. So any type of rainfall and anything leaching is allowing that drain field to actually do what it's designed to do, and that's to leach into the soil. That's what we'd like to see. All right, so this is another where we're looking at a gravel pack where we're putting some gravel in, and again, trying to create the environment where you can see or have good effluent absorption. Now again, us as owners and operators of these, we need to make sure that what we're putting into the system is going to help it as well, because again, as you heard me say, human waste, toilet paper, and appropriate pumping, and we should be able to do that because we try to build these, or most people try to get these built so that you have adequate treatment and then adequate discharge or dispersal into absorption into the soil. And with these gravel fields, you're creating that porous environment. You're creating an environment where it can be absorbed into the soil. And y'all saw this image earlier, but I still like it because it gives us this real life scenario of actually flowing out of the house tank into the laterals. And that's just an image versus the real life example of what that looks like with the gravel pack with the multiple laterals rolling out. All right, so I hit on this because again, I like to draw that connection between what we're actually trying to do with wastewater treatment. It's not just simply flush the commode, out of sight, out of mind. I think that's great. I mean, from our end, as far as professionals and the people in the business, if we can keep people educated and operating the systems properly, we can have good, as I've stated here, this effluent moving out into our field lines, filtering into the soil, percolating down. Hopefully by that time, there's good treatment and it's filtering into our groundwater so that it can be used downstream for somewhere else, another part of the state. All right, I kind of cherry picked this. I think this thing will, yeah, this is you should be able to see some actual movement here, kind of water coming in. We'll see kind of water filling up, scum layer rolling into the second chamber, moving out, moving into the field lines. I very much like to see visuals instead of just reading something. I do like to see it in motion and movement. I pulled this from some of my good friends out there in Texas. This is just a great visual that they've created. So again, it's just showing you that physical, actual process of wastewater moving through the system. I'll let it do it one more time. I got one more I'm gonna show. All right, so here we're looking at a little bit of an issue here because we're going to see an overload, and then so you're seeing the solids build, and ultimately you're going to see where it's getting into our effluent line and rolling out into the drain field, and that's when you start seeing actual issues in your drain field. In this image here, it's showing it actually moving on into the groundwater. And again, this is a still shot of that. So what we would see there, and sometimes you'll actually see some clogging. Those solids get into your field lines, you can clog, and it can start coming to the surface, backing up. And again, this is even more of the importance of knowing that we need to pump tanks on a frequency. And again, there's a great chart. I tell people, rule of thumb, every 3 to 5 years. And again, I realize there's a variation in that, but still thinking about how often you pump your tank, because you are going to have solids build up. They do need to be removed. All right. Again, this is just another compartment when we look at this is called a gravelless pipe distribution. So as it's rolling out, you actually have an access point on the end. We have never installed one of those, but I've seen a lot of that pipe, and I've seen a lot of that pipe put in the ground. All right, this is just a closer shot. Again, you'd have a long field line. And when we think about field lines, I've probably spent more time on it than I need to, but we think about how much water is potentially in those, how much water is potentially in a field line, because some of the field lines standard that I see in Mississippi are about a 10-inch line. So if you think about a 10-inch pipe for 100 feet, so we think about how much of a volume it can be or could be loaded into that system. So when we look at this gravel is here, think about the volume of water that could be in that pipe. It could be leaching out into the ground. And again, there should be a method to the madness with your installer on the size of your system, number of field lines, size of field lines, how it's flowing out. All right, leaching chamber. This is another one of those systems that on the front end, we have the two chambered tank, and then it has this leaching chamber on the back end. This is another system that I've never actually seen in place, but I know it exists. Depending on how that chamber lays out, it could be some stages. This, I've got a picture next where you may see the pipes coming out in those chambers for your leach field. All right, dealing with different soil types that may be less conducive for absorption, you will start to see these some spray heads or some movement of that liquid out. So this pump tank here operates very similar, almost exactly as we have lift stations, wastewater lift stations that may be in communities, maybe in towns, where you're having to physically move wastewater from one area to another, ultimately moving them to the treatment plant here. But this, when your effluent moves out, it's simply going into the tank, and once it gets to a certain spot, if you notice over here on this vertical pipe, there's a couple of, looks like 3 little floats there. Each of those floats, again, the same concept, you kind of have a low, middle, high, and once the water gets up, that high float will float up and it triggers the pump to come on. Once it goes back down, gets to a low float, it can cut off, but it's simply moving the water out, dispersing it. Hopefully it's treated, it's a land application. All right. Again, this is just a cross section of that, dealing with the gravel, laying those laterals in there. You have some clean outs here where you could access if needed. All right, so when we think about the mound systems, and there's even some other, and I think I get to it here in a second, depending on the part of the country, depending on the soil types, depending on where you are, this may be a common practice. We do not see that in Mississippi, mainly because our soils are, I'm gonna say, very receptive to on-site wastewater. You do see some minimal spray heads, but as far as the mound systems themselves, we don't necessarily see them, but it is another form of discharge of the septic tank wastewater. Again, this is just a cross section of the sand and the gravel where those pipes go. All right, so talking about plants, I think I touched on this for just a second. So essential for the system to function properly. Our plants take up the water and nutrients, they stabilize the soil, prevent erosion. They support beneficial soil organisms. So when we think about vegetation around our tanks, that's good. I harp on this a lot with people, especially here in the South. I would say majority, maybe not majority, maybe 5 out of 10 don't know where their septic tank is. So if you don't, then you're more likely to park on top of your tank or your drain field, construct something on top of your tank or your drain field, or plant things right on top of your tank or your drain field. So please be conscious of that, or if you're in the position where you're trying to help people or inform people of it, be conscious or help them be conscious of where their tank is. Parking on it, for one, I've seen it where people park on it, it caves in tops of tanks. Or if you're driving over field lines, a lot of times you can compact the soil real bad, then you don't get a lot of or good absorption. So constructing, people drilling holes or putting posts into it. So if you can find where it is, that's great. That'd be the best scenario. And then you make sure you keep it safe, get a wide berth. All right. This is another form of treatment. When we think about, y'all heard me mention earlier, when we think about aerobic, anaerobic. Aerobic is an air and very similar. Again, this is my frame that I put it on, and I've said this a lot over the last 20 years. When we think about mechanical treatment, anytime we start expanding above and beyond just the God-given method of natural breakdown and treatment of wastewater, typically what we're trying to do is trying to treat a larger volume or loading in a smaller footprint, smaller geographic area, because if you have enough land, you could conceptually build a lagoon to handle enough of your treatment. You just think about the number of people, the number of gallons per day that may be used, multiply that times a 45-day, hopefully treatment cycle, and that's going to give you a volume of water. You divide that by 7.5, and that's going to give you cubic feet. And then you just think about how big of an area do I need. So as we want to shrink that footprint and speed up the process, we typically move into some type of mechanical process just like this, where we're going to be adding some air. So what we're trying to do is I must say, is kind of speed up the process and add a little bit of treatment in it. So adding the air, of course, we're speeding up the process, speeding up the breakdown. And then with the chlorine tablets, a lot of times it's just a tube sticking out of the ground, and people will drop tablets in there, kind of keep it full as the wastewater moves out. It's no different than a chlorine contact chamber on a wastewater lagoon system. As the effluent is moving by, it's coming in contact with the chlorine tablets, rolling over into the pumping tank, and you hope there's a little bit of contact time for disinfection before it actually moves out. Again, chlorine is a phenomenal method of killing bacteria, given the right dose and given enough time. All right, here, just looking at a unit here requires oxygen. The anaerobic, the microbes require oxygen to live and grow. As we said, it consumes waste and bacteria, just kind of speeds up that process. But you do add, there's an expense to it, there's a cost to it. And we were on site with some systems 2 weeks ago now, and one of them had the aerator on, had one of these aired systems. And I told her, I said, well, you'll have good treatment. I said, if anything, I would think your tank's going to be fine. Just be conscious, you may have to replace this pump or motor at some point in time, and it's right there. So just trying to educate homeowners about what they have, the process, how it works. So again, air compressor, again, supplying the air, the oxygen transfers to the wastewater, basically kind of creating a good environment, speed up process, speed up the bacteria breakdown. All right. Looking at some disinfection, not sterilization, chlorinator, not swimming pool tablets. I encourage everybody to make sure to because conceptually, yes, when we think about chlorine, but do actually go to your distribution system that sells the proper disinfection tablets for wastewater treatment. And a lot of times what I've found, the tabs may look the same. Sometimes there's a difference in diameter and size, so how they fit. A lot of times your chlorine tablets will swell and stick, whereas your true wastewater disinfectant tablets will not. UV can still be a process for disinfecting, killing the bacteria. All right, so dealing with the distribution, we look at the pump and tank, spray field, or a subsurface drip. All right, moving along. So dealing with our spray fields, high potential for human contact, yes, no doubt. This is effluent, so it's not drinking water. I jokingly tell people often that have that, do not drink that, no doubt. Soil microbes are the final treatment, so you're hopefully thinking that your soil and the grasses are going to absorb and utilize this. Healthy cover crop is essential. Again, from everything we're dealing with residential, it's in a yard. So your desire is that the soil there is going to take up the water and nutrients. It'll stabilize the soil and prevent erosion. And again, everything I've seen, they've been in yards, not necessarily just a spray field. Provide food and habitat for beneficial soil organisms, no doubt. So this is an image of what we call the subsurface drip. Again, you're seeing this same process. I think you're seeing the same process where you may have a tank, what we may call pre-treatment, where your solids settle out, moving into a baffle, and then hopefully getting some type of discharge. And this subsurface drip, again, this is an image there, and I've got a picture next. So if you go to like the image, this is the way it lays out. So you have that goes into a pump and tank. You've got a filter because of course you've got much smaller lines. So you wouldn't want anything clogging those lines. And then this is how it would actually look. So think about your sizing compared to the little New Holland tractor there that's to the side. Fairly small, but again, we're trying to move that wastewater discharge out. So for one, it can be released, hopefully absorbed in the soil, used by the grass. This next picture is actually covered up. So again, it can be good, it can be helpful, beneficial to you. Same scenario, about the only thing I would think you would want to be driving over that is maybe your lawnmower, golf cart at largest, so that you're not affecting anything, rutting anything up or hurting your drain field. All right, looking at it, we think about feeding the system, we'll go back to that. So we think about conventional and aerobic systems. All right, so fats, oils, and greases. In our world, we typically know that as FOG, fats, oils, and greases. And I really, I'm gonna say, try to stress it as much as possible. But typically when we're holding a workshop and we're talking to a lot of homeowners about it, you'll see people just kind of wince because most people just pour this right down the sink drain, not realizing how it impacts. And I would say this not only impacts septic tanks, how it impacts large, all the way up to the largest wastewater systems that are out there. Fats, oils, and greases can be a huge detriment to those systems because they, depending on, again, if you're in the north or the south, they can cause huge problems with blockage. As it gets colder, they will turn to solid and they'll block up lines. A lot of your floats, as you saw in that tank earlier, those floats can get stuck with fats, oils, and greases. It can be bad. So, you know, in my mindset, pressing forward, if people can start to put fats, oils, and greases in the trash, and of course you'd want them to. I'm finding that we have to get into detail a lot of times, but make sure that it's cool. Don't pour hot bacon grease into a trash can, but pouring those into trash, trying to wipe them out with a paper towel prior to cleaning, prior to putting into the sink, if possible. I snagged this from the good folks in Texas. But we think about dishwashers and loading, and I say this as the person who does the laundry in our house. We always encourage people when we think about hydraulic loading, and I'll get to laundry in a second, but we're thinking about dishwashers as well. In a perfect world, you would have a fairly consistent flow and a fairly consistent loading into your septic tank from a treatment standpoint. But we all realize that's not necessarily true, because like, with my household, we probably wash dishes every day, but we wash clothes on the weekends. We have a lot of loading of that on the weekend. So you see what's getting put into your system. So you have organic loading, hydraulic loading. So thinking about what is going into your system. Garbage disposals, I put this on here or kept this on here. If you look at most of those, they're actually called incinerators, not necessarily garbage disposals. And I even have to stress that at my own house. Everything doesn't belong down there. As much as you can put everything in the trash, but it is an extra layer of help to move things through your system, or at least grind them up so that they're not affecting the lines of the tank. All right. I touched on this for just a second when we think about laundry, spreading out laundry so that we're not just heavily loading it in a system, because again, you can create some flushing out your system or your tank. It can be created with excessive loading. Again, these are all best practices when we think about our tanks, even though I realize it's not always possible. Touching on bleach, using bleach sparingly, because it is chlorine bleach, which is a disinfectant, which can kill bacteria. So if we're loading up massive amounts of bleach, that can have an impact on the tank if it's killing any of our good bacteria or killing a bacteria. All right. Again, harping on this again, knowing what we put into the septic tank or in the tank itself, human waste, toilet paper, I harp on that. It is interesting of what some people will actually flush down. I'm gonna say what they'll flush down a toilet itself, because when we go and do assistance with large scale wastewater systems, there's no telling what you'll see. So the fact that people have flushed these down the drain just baffles me. So when we think about how to have best practices, and I know we'll get there in some of our other trainings, but educating ourselves, educating homeowners, trying to educate people on the system. We need to educate ourselves if we're in a capacity to try to educate others as well about what is safe to put down it. Dealing with toilet paper, excessive toilet paper can result in sludge buildup. Specific types of toilet paper, no paper towels, hopefully no wipes. I literally, we moved one of my kids into the dorm this weekend, and his roommate had a lot of these stacks of what they call flushable wipes. And as I say, a lot of things are flushable. That doesn't mean they should be flushed. So, all right, just touching on this for a second, when we think about pumping, it is, I'm gonna say, paramount that we get the solids pumped out sooner rather than later. All right, thinking about how much should be in there, and I've heard usually if the solids are up about a third of the tank, it's time to pump. And again, a good pumper, a good operator that can come and pump your tank, they'll actually have a stick that they can put down there, and they'll gauge your sludge depth, kind of let you know what or how much needs to be pumped, or if it's time for pump. Here's a table here where we look at along the top, we may call our kind of our x-axis there. We're talking about the number of people in the household, and you may say, well, why is that important? there's a range across the country when we think about how much water does each person use per day. And I've heard it as low as 50 gallons, 65 gallons, upwards of 100 gallons. I usually go with 65. That's kind of my rule of thumb, especially when we're looking at consumption. And then over here on your y-axis, even though this table is inverted for X and Y, is the size of the tank. And then the numbers in the middle are the time frame in which you would pump. So if we use my household size of 6 people and I've got 1,000-gallon tank, if we were living there full time, it would say we need to pump every 1.5 years. And again, this is a kind of a best practices frequency of when you should pump tanks. So, all right. Avery, I've got 12:55. I'm hoping that leaves us a few minutes for Q&A if needed, but my contact information is up. Thank you.
Thanks, Jason. We do have some questions that came in. I have about
an answer. So
I have about 3 here, so hopefully we can get through these, and then any additional ones we can follow up via email. But feel free to keep dropping those in the chat, and if we don't get them to them today, I will share them with Jason afterwards.
Can I see the questions on here?
You do not.
Okay, great. Okay.
But I can send them in the chat to you, Jason. So the first one is in regards to how a septic system might affect a building foundation over time. So they're wondering how far it needs to be located from a house or building in respect to this foundation concern.
Ooh, how far should it be? I know, geez, that's actually a pretty good question, because everyone that I've either seen or been associated with, I mean, it's usually within, the tank itself may be somewhere between 10 and 20 foot from the structure. And then of course, field lines going out further from there. From a concern with foundation, unless there was an issue with the tank and you were having some, some very saturated soil that was making it soft and settle, I would think as long as you're, at least, I'm gonna say at least, 20 foot away, I would hope that wouldn't cause an issue. Because if you've got a tank that's installed properly, sealed properly, and working properly, you shouldn't have any moisture back. But to the best of my knowledge, I don't have a number on a code, where we, when we talk about wells and septic, we talk about 50 foot, 100 foot drain field. So those are fairly standard. But as far as away from the house, nothing is coming to my mind. I apologize on that.
All right, so our next question is a little bit of a qualifier at the beginning. So they say, I have heard of people arguing that the inlet/outlet tees are sufficient baffling. Why is the middle baffle wall needed? Is it really critical?
Ooh, and that is a good question, because I have seen some, what I would call, man-made tanks that it is a single tank with simply an inlet tee and an outlet tee. So I've seen those in operation, and I've seen it do appropriate treatment. It's my understanding that when we have that baffling wall in there, it can allow for, I'm gonna say, better settling on that front end chamber, and then rolling over, so you're less likely to get solids, the sludge layer, anything affecting that outflow. So if anything, I see it simply as an extra kind of added preventative measure of getting any solids, fats, oils, and greases or scum into the effluent pipe. So yes, I think you are correct. You can see those single tanks that don't have a baffle, and you can still get good treatment. From thinking about that right now, if that's all I had, it's a single tank, no baffle, I would definitely want to make sure I stayed up to speed on pumping of solids to not let it get too high.
right, I have one more question here, and then I think we'll save the rest for some email responses. So we will get back to you. But the last one is, how often do you need to clean effluent screens? Every time you get your tank pumped or more often?
How often do you need to clean that effluent screen?
Yes.
That is a good question. If it was me, I would probably set myself either a mental note or a calendar note. I would probably check it, either on a quarterly or 6 month cycle. Because from a tank pumping, if we just say rule of thumb, you're not looking at the scale, and you're not getting anybody to measure your solids. You're just pumping it every 3 years because you set a 3 year time frame. I would probably do the same with that effluent screen, and maybe just set a 3 month, 6 month reminder. Go out there and clean it, because even if you cleaned it every day, I mean, you're still cleaning it and helping your discharge. So again, I would probably just set myself a reminder. I would do it more frequent than I do the pumping. So
All right, well, that brings us to our time. So I want to thank you so much, Jason, for sharing your expertise with us today. I will forward all of these questions that we did not get to directly to Jason and give you your email addresses, so hopefully we can get you responses. Following
yep.
this webinar, everyone who attended today's session will receive a follow-up email with the slides from today, as well as a link to the recording. We also ask that you complete our evaluation following the session, which will pop up automatically on the screen, so you can let us know your thoughts, as this helps us plan future webinars on topics that are important to you. Thank you again, and we hope to see you at a future EFCN event. Do you have any final remarks for our audience today, Jason?
Final remarks. Again, my mindset was just kicking off the series we have here, hitting some high level notes about septic. So please tune in for the following 3 that we have coming up: the treatment processes, inspection tasks, and then optimizing wastewater systems. So that's all I got. Thank you.
Have a good rest of your day, everyone.